All right, so we saw that there's some limitations on what we can do with the plain old Mongo command line interface. So instead, let's explore what we can do instead programmatically. And to do that, we're going to be using a couple of technologies that are based on the Node.js framework. So Node.js, as you might know, is a command line interpreter for the JavaScript language that you can just give it a JavaScript file and it can execute it at the command line. It's fairly easy to install. If you go to Nodejs.org, you can download it from here, or you can install it also with Brew. Install Node.js, and I already have it installed here on my machine. And we're going to use a library that is designed specifically for Node.js to interact with MongoDB. The library is the Mongoose Library, and this is the website. I encourage you to again become familiar with both of these. Mongoose and Node.js. So let's use Mongoose to connect to a database and play around with some of the ideas that we've been exploring with the Mongo client. All right, so I'm going to open up a terminal, and in the terminal, let's create a quick Node.js project, and let's interact with the database. Let's see. Let's go to 5200. Let's go to 2018, summer. And in here, let's create a directory where we're going to do all our work. All right, so this is CS 5200, summer 2018. Okay, there's nothing here, right? Let's create a brand new Node.js project. Let's do npm init, and I'm just going to take all the defaults. All right, so this creates a package JSON as the it's the equivalent of the POM file in a Java project. A package JSON describes your project, and in here we'll create a hello world just to illustrate real quick, and that you can do pretty much basic or sophisticated JavaScript applications that you can run from the command line just by typing node. Node is the interpreter that you can run JavaScript files from the command line, right? Obviously, you can't do all the things that you can when you execute JavaScript on the browser. There's no user interface. There's no window. There's no DOM. There's no HTML. There's nothing. Instead, you have access to the file system, unfettered access to the network, access to databases and whatnot, right? So anyway, so here's a hello, and you'll see that yes, it executes JavaScript. So let's open this up with our favorite IDE. And so let's open. Bless you. 2018. There it is. Let's open that up. There we go. All right. So we have a hello.js. All right. So let's create a file where we can play around with Mongo, right? Connect to Mongo database. So to do that, let's create a file. Maybe call it Mongoose test.js. And right now it's empty. It has nothing in it. So to talk to Mongo, we're going to need to install a library to talk to the database. That library is called Mongoose. That's going to download Mongoose, install it locally, and then we'll be able to talk to the database. There we go. That's added Mongoose in node_modules somewhere down here. There it is, Mongoose. And it also downloaded all the things that Mongoose depends on. To use this, we can require Mongoose and load it up into our JavaScript. We can say Mongoose, require Mongoose. You can set the preferences. Language and frameworks, JavaScript, maybe ES6, maybe? Let's see. Okay, there we go. So the latest version of Node.js supports ES6, right? So we can use some of the more modern programming styles and syntax. So we loaded Mongoose. Require is just the same as like an import and loads libraries. And so to connect to a database is very simple. From Mongoose, we can take a look at some of the examples of their of how to connect to a database. And basically, it takes the variable, the object that is loaded from the library, and we already loaded it. And then we can use the connect function to connect to a running MongoDB instance. In this case, localhost running locally on our machine and to a particular database. Okay. Now, I'm not sure if I have Mongo. Okay, so I don't have a Mongo database running. So let's start that up maybe in a different tab. As I mentioned earlier, there's two executables that we care about. One is MongoD, right, to start the server, and there's the Mongo for the client to connect to it. So on a Mac, you'll need to use sudo. So this is MongoD. And there we go. So it's running. It's connected, listening at a particular port, and it's storing its data into data/db. All right, so that's running. We can also take a look at what database we want to connect to. So let's run Mongo. Mongo is the client that connects to the server, and we can look at the databases. Let's create one for this course for summer. So we'll create one, and remember it's use and then the name of the database we want to use. So CS 5200 summer 2018. And all right, so we switch to that database, and we don't have any collections right now. So we can say show collections, and there are no collections just yet. All right, so let's insert stuff in here programmatically from our code. All right, so we want to connect to that database. So let's copy that, and let's paste it in there. So that connects us to that particular database. Everybody good? All right. All right. So to connect to a database, to start manipulating this programmatically, we're going to follow the following pattern. Right? Just like when we were working on Java, we declare models, we declare repositories, we declare services, and we follow a particular structure. Here as well, we're going to follow some similar structure. Right? First, we're going to put all our models under a directory called models. Right? So we want to follow a structure. Right? So in models, we're going to have the description of the data that we're manipulating. That we're going to also declare all our CRUD operations to be able to interact with the data, with the database. So we'll create kind of like a DAO, right, that will allow us to talk to a database. So everything will live under models. Anything that has to do with talking to the database will live under here. All right, so if we want to be able to communicate and create data about users, let's create a model for users. Right? So let's do that. So this will be the user model. Right? And so let's create in here a couple of things. One of the things that Mongoose requires is to declare a schema or declare the structure of the data. As I mentioned earlier, MongoDB does not enforce any schema. Okay? Instead, that role has been moved over to the application level. It is at the application level. This is the application. That role will fall onto the application. So let's create a schema file for a user, right, and describe the user. So this will be user. This will be a schema file, and this is on the server side. Okay. So let's describe the structure of that data, and we'll say that this is a. We'll grab we'll need Mongoose to be able to do any of this. So let's grab Mongoose and require Mongoose. All right, once we have Mongoose, we can start declaring our schema. Right? Maybe this can be a constant. Constant, yeah. We can declare our schema. So this will be maybe a user schema. And this will be mongoose.schema. So schema are declared using Mongoose's schema class. And here's where we can describe the structure of the data. You can say that a user has a username as a string, has a password as a string. You know, things that we take for granted in a relational database that forces us to have a schema. Here, the database is not forcing us. Instead, we are creating an object, a class that can enforce some of this. So first name, string, last name, also string. Maybe the user can have a salary as a number, right? And maybe a date of birth as a date. Okay, and you have the full-blown data types from JavaScript. Okay, all right, excellent. So we have that. You could have maybe date of hire, the date that we're hired, and there we have. So we have a date. We can one of these, right? Maybe we instantiate when we instantiate this user. We can also instantiate their date of hire. Maybe they're an employee or something. So we can initialize that by instead of providing the actual data type, we can further configure this and say that the type is date. Right now, these two fields are identical in their data type. Right? The date of birth is date. The date of hire is also date. But if you use this syntax, you can be a little more verbose on what you want to configure. You can say, for instance, that the default value can be calculated on the fly. It could be either a literal constant, or it can be a function that can be called, and that whatever that function returns will be the value of that field when an instance of this user gets created. So this could be date.now. Date.now is a function on the date class that if you call it, it'll create an instance of the date object for the current date, right? So anyway, so that will be the default value of DOH. Right? If you don't provide me a value, I will instead instantiate it using the default. Okay? All right. All right. So same thing. We could do it with number. We can say that the default. The type is number, and the default value is starting at 25,000. That's the going rate, right? All right, so we have a schema. And now we can export the schema so that we can use it elsewhere. We can use module.exports and point it to the user schema so that we can use this schema elsewhere. So it's good practice to declare the schema in its own file so that it can be reused not only to declare data models or data access objects for the user only, but it can be combined with other schemas, right, to make even larger schemas. Okay, so yeah, it's a good practice to put it in its own file. All right, so we have a schema. Let's now create a kind of like a repository, or kind of a combination of a repository DAO kind of thing here. And the file we'll call the user.model.server.js. And in here, we're going to create what's the equivalent of a repository, CRUD repository we would have in Java, right? So let's do that. We'll still need Mongoose. So let's grab Mongoose. So require Mongoose. We'll also need that schema we just created. All right, let's grab the schema. So this is the user schema. We'll require it. Now, if we don't provide, if we just provide the name of the library like this, like Mongoose, Node.js will look for the library right here under node_modules. That's where it will find Mongoose. Instead, if we want to load something of our own file that lives in our own file system, you need to use a full qualified path. Right? In this case, it lives in the same directory, so we're going to say /, right? Because the schema lives in our own directory. So there's our schema. All right, so we have both the Mongoose and the schema. We can now create the low-level CRUD repository kind of thing, right? That we're using the equivalent of a JPA, right? And we could create it by using Mongoose's model function. Okay, so let's create that. So const user model. We can use Mongoose. And then dot model, right? And then we're gonna name this this CRUD repo. We're gonna give it a unique identifier. We'll call it user model. And the type, right? The type. What is it that we're CRUDing? What is it that we're creating? So we'll need user schema. There we go. So it knows that. So what user model is going to give us is all the CRUD operations, the low-level CRUD operations to manipulate users. Right? It will have the create, the inserts, the updates, the deletes, the removes, the finder methods will be there. So it's really the same role of a CRUD repository in JPA. Yes? Same exact thing. All right, so we have that. We have the model. One thing that I probably forgot here is that once we declare the schema, another thing that we might want to put in here is map it to an actual collection that we want to store it to. Right? Very much like in JPA, a class, you annotate it and say entity, right? And with the entity, you're basically telling the name of the table, right? It's the name of the class, right? So here we have to be a little more explicit. We can configure and use the collection meta keyword, right? And say that we want to store it in a collection called user. So all these will be the fields in a collection called user. Okay. All right. So once we have the model, right? User model has all the functions we need to talk to a database, right? But that's our very low level CRUD operations. Yes. So we need to create something like a DAO, and in the DAO, the responsibility of the DAO is to provide a higher level interface, right, that allows us to talk to a database without the idiosyncrasies of a particular of a particular library, right? Just like in JPA, JPA has very generic functions. You know, find all, for instance, right? Or find by ID. Those are very generic functions. Instead, we like to wrap those around something that is a little more high level, that says, for instance, find user by ID or create a user or something like that. So that's what we're going to do here. We're going to create a function like that would allow us to maybe create a user. That would allow us to actually instantiate one of these users. So you can say user model dot create. So create is a function provided by Mongoose. So this is the low-level CRUD function that the API gives us. We're wrapping it into something that is a little more higher level, create user. Okay, and so this is create user. There it is, right? This is going to return. This returns a promise, right? Because Node.js is going to be its own process running in its own thread. It needs to talk to a database that is running in a different thread, right? So these are, or it might even be running, halfway across the world, right? So this is an asynchronous call that connects through the network and talks to the remote database and inserting, doing an insert. Okay, a couple more here. Let's do a find all users. It's a function, takes no arguments, and it's going to return user model dot find. Again, this is the low-level library's CRUD operation to return all the records in the database. We're just wrapping it in something a little more higher level, right? So it's kind of like a DAO. All right, so let's start with these two, just these two. And what we're going to do is that we're going to expose the API so that somebody else can call these functions from outside, right? So let's create here a constant API that contains create user and contains find all users, right? And then we can expose this. Well, I guess we can expose this right here. We can say module.exports equal. So we're exposing this object, this JSON object, right, that can be now used from outside of the this particular context. All right, I think we have enough to get started, right, to play around with interacting with the database. All right, so let's go back to the Mongoose test. We have a schema, we have a model. We can start actually doing things, right? So let's create a couple of folks here. Remember, the collection doesn't even exist, right? The collection is there's nothing in the database. So let's require our model. We can bring in the model, right? So const user model that we declared where? Where is it? I think no, that's not it. It's let's see. We are here module Mongoose test. To grab the model, we need to go down to models, down to user, and then down to user model server. Yes? All right, so let's do that. Let's go down to, let's start with models, down to user, and down to user model server. See that? Okay, we have that. Now that we have the user model, we have access to all those functions that we had earlier. Right? We have user model dot, we can create a user. We can create a user, maybe provided with a JSON object. Maybe we can create a const Alice with an object, just a JSON, just a plain old JSON object, no big deal, with a username Alice and a password also Alice. Maybe first name Alice and last name Wonderland. Okay, so we have Alice represented as a JSON object. Notice that we're not providing a whole bunch of other things: date of birth, date of hire, salary. We didn't provide any of that. So we can provide Alice as an argument to here, right? There it is, and we can now run it. Right, we can run it from the command line. Let's go to the command line. Let's see, where is the command line? I think it's here. Are we in the right place? Yes, we have Mongoose test. So we can run this from here. So Mongoose test, and we can run it from here. So it executes, and let's see if it did anything in the database. If we do show collections, notice that now we do have a user collection that wasn't there before, right? And we can explore what's in there. We can say db.user.find, right? And indeed, we have Alice in there. Notice that we have Alice, the username, the password. Notice that we have the date of hire. We have the default value of today's date. Okay, the salary's there, right? The default value is there. But notice that none of the other ones are here, right? Because they didn't have any default values, right? So they're not wasting space. But notice we do have the underscore IDs there that was generated. Okay, now that we have something in the database, let's try and retrieve it. Let's go back here. Let's stop it for a second. And so for now, let's comment out this create user. Instead, let's now try to retrieve that data back from where it's in the database. So let's do user model, and we can find all users. Remember, so this is going to return a promise, right? Because it's an asynchronous call, right? And so this is going to return all the users, which we can then maybe just display them on the console. All right, so let's try that. Let's run that. And indeed, notice that Alice came back as an array, right? Inside of an array. So if there would have been several other users, it would have been listed there with all the values and whatnot displayed here. Everybody okay? All right, excellent. So we have some of those examples. Let's expand the model a little bit. What other use cases? So typically we want to be able to have all the CRUD operators plus the find by ID. So those are the most common ones. If we go back to the model, we can implement all the other ones. For instance, we can say find user by ID, right? That might take as argument the user ID, and this would do something like user model dot find. So again, we're wrapping a low-level API with something a little higher, and find would be something like this, where the ID, the underscore ID, might be equal to the user ID, right? That we're passing as an argument. Yes, and we can expose that as part of our API. All right, so let's play around with that. Let's see what that looks like. So this would be user model. And we know that Alice has a particular user ID, right? So this is find user by ID. And we know that the ID is this one right here, right? So we can copy that. And we can just pass it as a string, right? So Mongoose makes it easy for us to pass in an ID just as a plain old string. Actually, it instantiates an object ID, which then it uses as the pattern matching, right? So let's do a then here and display that. So then, so this is user, and we'll do a console log user. Okay, so let's try that again. Stop this as I run that again. Notice that it came back with the same exact thing, an array. Right? Even though there's only one Alice, okay, and that's because we're using the find. This find here always returns an array, even if it's just one value. Okay, even if it's just one value. So what Mongoose does is that it provides a couple of syntactic sugar functions, CRUD operators. For instance, for things that are very common, for instance, if we know that there's only one of these, right, find one kind of wraps the finder with retrieving the first element in the array that comes back, right? So if we do that and we stop and we run that again, notice that now it returns just that one object. Okay, all right. Actually, because it's so common that we are retrieving things by ID, that's such a common use case, it also provides another syntactic sugar that allows you to retrieve find something by ID, find by ID, and here instead of having to provide an object, we can just pass the ID. That's another syntactic sugar. So let's run that again, and again we have Alice. Everybody good? All right. All right. So other things we might put in here are maybe find user by credentials and provide here an argument of username and password. Right, where here we might use a user model dot find one, because we know just only one person with that combination of username and password, right? And then provide the matching of the two fields that we're looking for. So password, password. Okay. So for instance, here we could say find user by, well, let's leave that here. Let's copy that, comment it out, and let's have this here. So find user by, oh, I didn't expose it. We didn't make it available in the API, so we can't see it from out here unless we expose it, right? So yeah, so find what? Find user by credentials. There we go. And so this would be Alice and Alice, right? And we can run that, and hopefully it'll be Alice again. Maybe not. Password. Did I spell that wrong? Password. There we go. Computers are always right. There we go. So we can retrieve that one record. Everybody good? All right. Excellent. All right. So what else would we want in here? We would probably want be able to update, right? So maybe update user, and probably that is going to take as argument the user ID and the new user values, right? So new user, and we would update that by doing something such as user model dot update, and the update might take as argument first identifying the user that we are updating. It's the one whose ID is equal to the user ID parameter that we're passing, and then the things that we want to update. For instance, we might want to update only a few things. For instance, we might not want to be able to let them update a username, for instance, right? So we might say that you can only set, for instance, maybe the first name to new user dot first name, and set maybe the last name to the new user dot last name. Right, and maybe we can also allow you to set the salary, so salary to new user dot salary. Right, so those are all the things that we're allowing folks to change, perhaps. Okay, right. So from the test, we could have maybe Alice or new Alice. Leave the username and password, but here we might change this to Alicia. Wonder Woman. And the salary has went up to 250,000. Right. So this is the new data that we're passing around, and now we can use the update here, user model dot update. Oh, we didn't expose it, so that's why we're not seeing it, right? Well, let's forget. So update user, let's expose it through the API over here. And this would be update user. We know the user ID, so let's grab that. So that's the first argument. And then new Alice. Right? And right after that, what could we do, perhaps? We could do a then, and maybe retrieve Alice after Alice has been modified. We could do that, right? So this is going to come back as a status. What update comes back with is a status saying how many records were updated, right? And things like that. So we can maybe display and do a console log the status. We do a console log the status, and then right after that, use user model again. Use user model to find user by ID and retrieve Alice again. Retrieve Alice again, right? And then do a then, and here's the user, and we just want to display Alice. Console log the user. Okay. All right. So let's try this out. See if it explodes. Let's stop this and let's run it again. So notice that indeed we were able to change Alice's salary, the first name and last name. We were able to update it. We updated it and then retrieved it. Notice that the first thing that comes back from the update is the status, meaning everything was okay. One record was updated, right, and everything is fine. Plus the object that we just updated. Okay. Notice that this syntax is a little bit hard to read. Notice that we have two thens instead of another, right? It's very common that when you have to call multiple asynchronous calls, that you have to nest them one inside of another, right? So if you have multiple of these, the code becomes very, very hard to read. You have lots of these nested, asynchronous calls one inside of another. So you have this very diagonal. So here we have the beginnings of that, right? This code starts to begin to look kind of awkward, right? That this diagonal, right? And that's one of the reasons why they even invented these kind of APIs, these kinds of promises, right? Promises allows us to break this ugly syntax, right? By doing the following. Instead of doing this, right, we could instead do the following. So we could do return. Right, so we could return the promise. Right, this returns the promise. That means that this is the promise can then be this whole user model update user. This whole thing returns a promise. So that allows us to move this out of here and move it down here. See that? Right, so that syntax allows you to now have the code just nice and straight, right? Almost as if it were synchronous, right? Almost it looks like it's synchronous, right? So you eliminate the need of these heavily nested asynchronous call, and now the syntax looks much easier to read. Okay, so let's try fixing this. Let's maybe change only Alice's salary. She's going really up the chain here. So we're going to set only the salary. Actually, no. Let me change this Alice 1 and Wonder Woman 1, and let's change her salary to 3. Just for a second. There we go. So we changed Alice, and let's rerun this and make sure that this worked. There we go. So it just works exactly the same way, right? So we changed Alice's last name and her salary. Right? Now, if you don't really care of which fields you want to change, right? If you don't really care that I only want to change the first name, I only want to change the last name, I only want to change the salary, right? And just I'll change whatever you send me. Whatever field you send me, that's what we're going to change. Okay. What we could do instead, that is much more convenient, right? And notice that this object here, it looks very similar to this object right here, doesn't it? Right, it looks almost identical. The structure of the object looks identical. So it's really this object right here, isn't it? New user is just that object. So we could instead of this, let's comment that out. We could just use new user. new user already has first name, last name, salary, already has the structure. There's no need, right? If you don't really care to validate to that I'm going to only let you modify this or that, I'm just going to let you just whatever you pass me. Whatever you pass me, I'll update. Okay? Here, I could just say I just want to update the salary. Right? Her rocket career. And we just pass that along, right? Without touching everything else. Right? We're only changing that one. And this becomes so much more easier to, again, if you need to stop, right, and validate, you could do the validation right before you do the update, right here, right? So anyway, so let's try that out. Right, so notice that indeed we're able to change just that salary without having to mock with everything else. Okay. Anyway, let's see. Let's not create another user because I'd like to be able to remove a user and just demonstrate removal. So removal will look something like this. It'll be delete user, right? And typically that will be, you'll tell me what user ID, the ID of the user you want to remove, and then we'll just remove them. We'll use the low-level user model and then remove. And remove takes a JSON object that identifies the actual object that we're removing, so user ID. There we go. Right? And we're going to expose this, expose the delete user. Okay? Well, before we delete, let's create another user, so that just only so that we can remove them. Let's create Charlie. So Charlie here is Charlie, and first name is Charlie, and last name is Brown. And let's insert Charlie Brown. Where's our create user? Let's uncomment that and let's add Charlie. Right, and after we do Charlie, let's find all users, and display all the users just to verify that indeed Charlie was inserted. Okay, so let's stop that and let's run it. Okay, notice that we try to insert Charlie. We ask for all the users, but it's only returning Alice. Right? If I go to the database. If I go to the database and ask for all the users, Charlie's there. All right, what happened? Pretty. The two objects are there. What happened? Why? Notice that I didn't make a mistake, right? I first created Charlie, and then I asked for all the users. You see that? Okay. What's happening here is that I've just created a race condition. Right? These two are two asynchronous calls. Right? This one is executing, and it probably happened that it didn't get to finish before I went to fetch all the users. Now this maybe would have worked. Right? This might cause kind of like an intermittent bug. Right, where sometimes I do get the users right after I added, and sometimes I don't. What's going on? Right? And these are the worst bugs to try and debug. Right? And they're very, very common when we don't understand how these asynchronous calls work. Right? To be able to guarantee the fact that I first insert and then I fetch, right? I need to make sure that I first get a response back from the create, that it was successful, and then I can go back and fetch them. Yes? So let's create yet another one. Let's create Dan Brown, another Brown. And so here's Dan. So the way this should have actually been written, is that this returns a promise right? After it comes back from the server, this is the way it should have been written. And then here, now we're guaranteed inside of this then. Now we're guaranteed that it has been inserted, right? And so now we can want, if we want, right? We can go back. We can go back to, oops. Now we can go back to the server, right, to the database and actually fetch, yes. But again, I'm doing this diagonal thing again, right? Which if I do a couple of these, it starts really hard to read. So a better way is to return this inner promise and move this, right? Move this down here, right? And then print out all the users. Make sense? Right? All right, so let's try it again. Let's try it again. We now have 2 users in the database. We have Alice and Charlie Brown, and we're about to insert Dan Brown. Let's see if we fix our problem. Our problem here was showing that we inserted 1, but it was we knew there was 2, but it was only showing 1. All right, so let's run it again. Notice that indeed now we do have the 3 that we're expecting, right? The 2 that were already there, plus Dan Brown is now inserted. We now guarantee the order of execution of these things, right? So be careful, right? Whenever you have multiple things happening, you need to handle these sequences. Okay. All right. Excellent. So we have 3. We have enough to demonstrate the fact that we can remove things. So let's comment this out. And we don't need Dan anymore. And in our model, we make sure that we have exposed the delete user, which is returning the promise. So let's go back here and actually interact with it. We're going to say user model dot delete user, and we're going to remove. Let's see, who should we remove? Remove poor Charlie Brown. So remove Charlie Brown here, right? And to verify that indeed we've removed it, let's go and fetch the users again and make sure that we only have 2 left, right? But again, I'm not going to do the same mistake as before, where I remove and then right after I try to find all users, right? That's wrong, right? This might work, might not work. I don't know, right? It's 50-50. Okay, so I don't want to create these race conditions, right? Whenever you're talking to multiple when you have multiple asynchronous calls, you have to guarantee the sequence, right? So the only way to guarantee it is to wait until it comes back from the server, right? Now I am guaranteed that I have deleted the user. I am guaranteed, and now I can do whatever I want, right? I can now go and fetch the user. So I'm going to return this. I return this, and here I get back all the users. So users, and then I can display them. Make sense? All right, so let's try it out. So we delete, so we remove Charlie. Let's try it out. So there we have Charlie. Let's make sure we have that also in the database. Yeah, we have 3 users. There they are. And so let's run our app here. Let's run it. And notice indeed now we only have Alice and Dan, right? And Charlie Brown is no longer with us. Right? We only just have those 2. Make sense? All right, so excellent. So we have we have completed what we have so far, a minimal DAO, right? This is playing the role of the DAO, right? Abstracting low-level API Mongoose calls, generic calls, with a more specific to our particular use cases. Yes, right? There might be more here. You might be adding more things that go along. There might be things that users are related to, departments and bosses and managers and jobs and projects that may be enrolled in. So those would be other data models that we might need to do. Right? So let's explore how we would create relationships between a user and other things, right? Maybe do an enrollment. Okay, so let's take a look at that now.